Okay, we are still in Blender, of course. So let's have a look. We wanted to do this scene in cycles. We change our render engine to cycles from Eevee. We make sure that we can set it to experimental, and then we need to make sure we have device GPU compute. If that doesn't show up for you, you might want to check your preferences, and under system, you make sure that under cycles render devices, your cards or whatever you're using is enabled, and then it should show up here. So the good thing is, and it's going to make this tutorial, this part of the tutorial quite short, is that Cycles uses the same shader setup as Eevee. So we have already done the work for Eevee, so we're basically done. Okay, next video. No, I'm kidding. We need to do one thing slightly different, is that the volume behavior is a tiny bit different. So in order to get the same result that in terms of looks that I have in Eevee, I need to change the volume scatter. That's why I have an additional node here to the value quite drastically, and I need to actually also change the volume, the color. So this one uses does some kind of automatic inversion, I don't know. And if you want it blue, you actually need to make it blue. So there's a couple of things I wanted to mention before. So we can take a look. It's the thing with cycles is that, let's see how quickly it goes, or how not quickly it goes. Of course, so cycles is a proper render engine, and it takes a few seconds to load in, and then you see how it will take quite a while to resolve and not have this so noisy. So it's, in terms of viewport, it's a bit difficult to use. I mean, but you can see already that the quality is quite a bit different, and the look of it is quite a bit different than to Eevee. For example, here, if we use the other volume, you see like this looks completely crazy, right? And it doesn't look like the same as in Eevee, but it looks cool nonetheless. But we want to have the same exact feeling, so that's why I had to experiment and change it to this one. It looks very cool. I think it's very, like, the Cycles has great quality. It feels a tad slower than Octane, for example, but the good thing is that we have done everything in Eevee already. We don't need to redo our shader setup, only tweak it maybe here or there. But in terms of like practicality, it's really great. You can do your previs in Eevee, and then you can actually switch it to Cycles and render out your final frames in that one. A couple of things that I would recommend, and you can check. There's plenty of videos online on how to improve and speed up the Cycles render, because out of the box it's a tad slow. So a couple of things I wanted to mention for you guys to look at. So we look at, like, for example, the samples, right? You can play with those. You can set for how long this is supposed to run within the viewport or for the final render. So you can set it to however many thousands of samples you have patience of waiting for, or how many ever GPUs you have in your machine, and depending on how quickly you can resolve this. So a couple of settings we need to look at besides the sampling is, of course, I mean, you know that the more samples you're going to add, the cleaner the image will be, but also the longer it will take to render. We want to look at, not simplify, but in terms of performance, we want to have a look here. So the tile size is basically these big tiles that you're going to see in the render window, and not to make it technical, because I also don't know exactly why it is that way. is that you want to, for GPU rendering, you want to have the tile size bigger, around maybe 250 or whatever, and if you're CPU rendering, you want to have it smaller, maybe around 16 to 32. Some people recommended actually activating the CPU alongside the GPUs, but for me that really decreased the render times drastically. Increased the render times drastically. So I opted not to do it. So I'm running purely on the GPU here. So just for comparison's sake, my cycles is running on two 1080 Ti via eGPUs on my Mac, and Eevee of course is running off the internal card, which is a Radeon something 16 gigabyte RAM that's driving the display. So that's kind of the comparison that we're doing here, right? And in case you don't know which tile size to use, you can activate this little plugin that is built into Blender. So if you search for tile, you can activate this render auto tile size, and it will activate this little thing here, and then you can press it, and then it will adjust the tiles according to your setup and the screen resolution and everything. Excuse me. You see it's coming along a little bit here, clearing up in some areas. So we close that. We also can check light path, and these are just some recommended settings I found online. You want to set the total bounces to 6, and here the diffuse, glossy, transparency to 3, transmission volume to 4 and 2. It depends. If you have no volumetrics in your scene, you can set this to 0. If you have no like transparent objects in the scene, you can also set this to 0 without much of an impact in the quality of your render, but it should render faster. So with this kind of setup, you can actually, I could like cut my render times in half, which is quite significant. So a 4K render would take me like 2 hours before, and I cut it down, I think, to 45 or 50 minutes. And there's not a noticeable difference in the final quality. These are the optimizations you should do. We can also, and now I need to find it again. We should also look at denoising. So if I can find where it is, yeah, here. So it's like an extra layer. If you close all this, we activate the passes again that are here. I'm using the same as before, kind of like a Z-pass, mist pass. But you want to activate denoising. So there's a couple of ways that we can actually do denoising in Blender, and that's great. So we have, for example, this denoiser here, which is built into Blender, and it's okay. I'll show you the difference later on. That's the one I've used for this image. So denoising basically does like a post-processing on your image. Just kind of imagine it like a Photoshop filter, but way more advanced. So it will give you, in the end, when you render this out, a different pass, the noisy pass, and then a denoised pass. And then you will see that some areas that are noisier, it tries to do some kind of manipulation and some kind of magic, computer magic, that denoises the image and gives you a cleaner image without actually having to do so many samples, right? So the idea is that to reduce render times, but still get a very, very clean image. So this is the one built into Blender. There's 2 other options which I heard are very good. I haven't tried them yet, but maybe you should definitely check them out because they're supposed to be better than this denoiser. So I'm just pulling them up here. So you see one of them is here, remington.pro/software/blender denoise. Or you can just look for denoise for Blender. This is called the Rapid AI denoiser. It's actually using NVIDIA's new optics AI accelerated denoiser, which I heard gives very, very good results. So it's going to be in here, in this tab. Once you install it, it works only on Windows. Because it needs to download some kind of extra libraries from NVIDIA once you enabled it. But it's installed like any other plugin, and it gives pretty great results, I heard. So you kind of get a lot cleaner images. You can see here it compares to the Blender denoiser, right? Looks a lot better. But then there's also something new coming from Blender itself. So in November, it's launching 2.81, and it comes with the Intel Open Image Denoise. But for this one, you have to go through the compositor. I do not I have not played around with either of these, but I heard this one here is supposed to be the best one yet. So I think if you're really into that, and you might want to check out, there's a lot of videos already online on people trying it out, and I think there's gonna be a really cool future denoise options we have that just gonna make rendering faster and improve the image quality. So here it has run through its 1,000 samples, and it looks grainy as hell, but that doesn't matter. We can see what's going on here. So once you like whatever you have, you go to render image, and then it's going to take some time. So for me, with my two 1080 Ti, I had like a 2K, the 2K frame that I have in the current settings is going to take me about 10 minutes or maybe 12 minutes, and then the 4K frame 4 times longer, so around 45 minutes, and for 2,000 samples, and then the denoiser on top. So I rendered out a 2K frame because I'm very impatient, and we're gonna look into that once we start the comparison. So that was very quick, but I mean, that's really all you need to do. So because we're getting basically the shaders for free when we've done already the work in Eevee. And I think the quality is really quite good. It's really quite good. Okay, so now let's move on to all things Octane.